Good morning. I'm Eric Schumacher Rasmussen, the editor and VP of Streaming Media and the conference chair for Streaming Media West Connect. Welcome to day 4 and to our all-star panel talking about accelerating the adoption of AV1. I want to get right into it, but have a few housekeeping notes. Once again, I will refrain from guaranteeing we're going to see you in person next time, but we do have Streaming Media East on the books for May 24th and 25th, 2022. And we will also be doing another Connect virtual event in February. So keep your eyes open for more information about both of those. A few housekeeping notes. If you have questions for our panel, please put them in the Q&A rather than in the chat. It's just easier for our moderator and me to keep track of questions if they come in the Q&A panel rather than the chat. Also, we do have live transcripts turned on. If you want to turn those off, go to the bottom of your Zoom window, click live transcript and click disable, and that will turn them off. Finally, just for being here, you are entered into a drawing to win a $50 Amazon gift card. And we will announce the winner at the end of the panel, though, so you got to stick around to win. And I don't think that'll be a problem, to be honest with you. I'd like to thank the diamond sponsors for all of Streaming Media West Connect, and that's Video Guys, Limelight Networks, Conviva, and Signient. And right now, we've got a quick video message from all of them. Bill, roll it.
VideoGuys.com is your source for PTZ cameras that fit productions of all sizes.
Add multiple camera angles to your production without adding operator. Perfect for houses of worship, corporate AV, education, and more. Video Guys offers cameras from PTZ Optics, Bird Dog, Panasonic, and NewTek. Control these cameras using an IR remote, control app, or hardware controller with serial or network connection.
Go to VideoGuys.com or call us at 800-323-2325 for help finding the camera that's right for you.
In this era of streaming video, we are pioneers, helping make your stories more vibrant. Conviva lives in billions of apps on devices all over the world, measuring trillions of data points each day to provide real-time insights for your content, ads, and social. Conviva. Every stream, every screen, every second.
And I would also like to thank the sponsor of this panel, Xilinx, and Xilinx's Sean Gardner will be one of the people talking about accelerating the adoption of AV1. So with that, I would like to introduce the moderator of today's panel, Tarek Amara from Twitch TV. Tarek, please join us.
Hey, good morning, Eric. Good morning, everyone. Last minute, some audio issues. Hopefully you can hear me well.
We can hear you, and I'll let you take over from here.
Lovely. Thanks, Eric. Good morning, everyone, and thank you for attending this panel. Thanks for people who wake up at 7 a.m. on the West Coast. That's pretty early and it's pretty still dark here. My name is Tarek. As Eric mentioned, I work for Twitch and Amazon. And today I'll be very happy to moderate this panel to have this conversation about AV1 and how people have been working hard to make progress and facilitate adoption. We have a packed agenda today, so without waiting, I'm going to start introducing our panelists. So we have with us today, let me share my slides first, and then we can get started. Right. We have with us in order, we have Anush Moorthy. Anush is the manager of video and image encoding at Netflix. Anush got his PhD from University of Texas in 2012. He previously worked for Texas Instruments and Qualcomm. Anush joined Netflix in 2016, and he's now managing the video and image team. Anush's team's focus is video quality assessment, image and video compression, and computational vision. Anush, thanks a lot for joining and welcome. Next, we have Sean Gardner. Sean is head of video strategy and BD at Xilinx. His focus is on transcoding product for data center and server solution and applications. Sean's team is driving a wide range of real-time transcoding solution on FPGA and ASIC, and that includes open and royalty-free codecs such as VP9 and AV1. Sean is very passionate and very active around codecs, streaming technology, and AI optimizations. Sean, morning, and thanks for joining us.
Good morning. Good morning, everyone. Thanks for joining.
Next, we have Matt Frost. Matt is the chairman of the steering committee of the AO Media. He's also director of product management at Google. His team is putting lots of effort in improving the media experience on web, mobile devices, and connected devices. And his team is part of the team who built Google's first transcoding ASIC, the Google VCU, announced earlier this year. Previously, Matt was CEO of Onto Technologies that was acquired by Google in 2010. Matt, thanks for joining us.
Thanks, Tarek. Happy to participate.
Next, we have David Ronca, Director of Video Encoding at Facebook. David is responsible of video processing across the family of Facebook products, such as Instagram, Live, Reels, and Watch. We all know David formerly led the Netflix encoding team that helped grow Netflix from a single browser, I believe that was Internet Explorer, to millions of devices nowadays. And he developed great innovations such as VMAF, which the industry is using massively these days, and complexity-based encoding. David is a strong advocate for computationally efficient video encoding to meet the rapidly growing demand of video services in a sustainable and responsible manner. I would call that green encoding. David, good morning and thanks for joining us.
Hey, good morning, Tarek. Thanks for having me.
Perfect. Last but not least, we have Nathan Eggy. He's a senior manager, audio and video encoding at Amazon Chime. He's a former head of codec engineering at Mozilla. He's a video and audio codec tech expert and gave multiple talks about 264 and AV1. He contributed to Ravi and David projects, and he preferred to call himself video codec engineer after all these years of experience. He's a member of ZIF.org and Videoland nonprofits. He's a strong advocate for open and royalty-free standards, and I think AOM and AV1 got his heart's desire here. Nathan, welcome and thanks for joining us.
Yeah, thanks, Tarek.
Perfect. Without keeping you any longer, I would like to kick off the conversation by giving the floor to the panelists to tell us more about their companies, views, and their progress and involvement into the AV1. And with that, I would like to start with Anush. Anush, the floor is yours.
Sure. Quick summary is seen on your screen there. Netflix is one of the founding members of AOMS. Everybody knows, and there's several members here on the panel as well, right? In this, we started our efforts back in 2015, and obviously, in order to do that, we started thinking about it much earlier than that, right? And it was officially announced in 2015, and then through the next 3 years, we helped with standardizations. And during the standardization activity for AV1, we contributed several tools, test conditions, and so on. There's also a lot of syntax that we contributed to AV1 format and the ISO BMFF spec and so on, right? We continue to do so. And then once the codec is standardized, we work towards ecosystem support. So as I maybe pointed out at the head of the slide, there were 3 main axes that we contributed to. One was the standardization, so that's what I covered earlier. And then the next part is the ecosystem and the productization, and you will see that in the rest of the slides, right? So from 2018 onwards, we worked with increasing the ecosystem support by working with other companies such as Intel with SVP AV1, funding optimizations for the decoder on David, which is one of the most performant decoders out there for ARM and x86 on 10-bit decode, because that's the profile that is most relevant to Netflix streaming, right? And we've also done the productization angle where we've launched AV1 on Android, and we had a tech blog around it in 2020, so it's been a while now. And this is fresh off the press. So we are going to have a tech blog about AV1 streaming on televisions hopefully this week or next week it'll come out. So we've enabled streaming on a bunch of televisions which support hardware AV1 decode. So as you can see, we've consistently stayed with the ecosystem for AV1 rollout.
Indeed, I think the TV announcement is really exciting, and I know lots of people have been talking about multiple TVs nowadays support AV1. Thanks, Anush. Next, I'd like to ask David to drive us through this amazing chart. David.
Thanks, Tarek. Yeah, so Facebook has been investing primarily in encoding and decoding hell for AV1. On the encoding side, we've been partnered with Intel and Netflix on the SVT AV1 encoder, and we've also been partnering with Netflix in the David optimizations because obviously until we have a good decoder answer or decoder story, we can't really do a lot. I just want to quickly talk about the encoder story though, because I think this is what's really kind of exciting about AV1, really exciting for me because it connects with my current passion around sustainable and energy efficient compression. So this is the most recent, hot off the presses, Intel will be talking about this today, comparison results of codec comparison results. And it's looking at several generations of encoders from VV-Inc, SVT AV1, LitVPX, X265, and X264. In this graph, the horizontal axis is encoding time. And I would mention that the scale is exponential, so each vertical bar is an order of magnitude. And then the vertical scale is the quality. So in the graph, lower to the left is better, right? Low is high quality or high efficiency. The left is computationally efficient. So what we have now is the latest work on SVT AV1 has given us this incredibly beautiful curve that shows AV1 operating in the entire spectrum of use cases from the extremely high quality or the high quality premium experience where you have millions of views of a single file, where you want to invest a significant amount of compute to get an efficient codec, all the way down at the low end, where you have very few views. Perhaps this could be security videos, this could be low watch user VOD or others, where you really have to be careful about how much compute you spend processing that video. And so you see we have this curve that takes us all the way down to the computational equivalent of X264 very fast, but you can see in terms of efficiency, significantly reduced bits at that level, at that level of compute. And this ties in with the Facebook position that because compressing video requires power, the true value of a codec, historically, which has always just been stated in, hey, this new codec saves this many bits versus these codecs. But the true value of a codec should be expressed not just as bits reduced, but in terms of cost benefit. The cost, of course, is the energy consumed to reduce those bits. And reducing bits in a video really is only valuable when that reduction results in downstream efficiencies greater than the cost, the actual computational cost of reducing the bits. Again, the easy way to understand that, on one end, you've got millions of views of like the latest season of Stranger Things, which I'm looking forward to. On the other end, perhaps you have my personal social videos, which nobody watches. And then everybody else lands somewhere in between. And the beauty of AV1 is it's able to hit all of these points. And we actually have heard this from people in the industry talking about this new world. What does the new world look like with so many codecs? And the answer has been, well, we have all these use cases and we need all these codecs, each one to touch a use case. And I'm thinking, we don't need more codecs, we need fewer codecs. And so I'm really, really happy that AV1 is showing that it can be one codec for every use case in the video domain. And I'm also, we're happy to see that energy efficiency is becoming a very important factor. Finally, I want to mention, if you look to the lower right, far right, you see what we believe is a hypothetical ASIC AV1. There are ASIC AV1 encoders already. We have not run tests, so we could not put real data on this. So I just made my best guess on that. Anyway, this graph, I think, illustrates in a single slide why Facebook is really, really excited about AV1. And in 2022, we're going to be making a significant deployment of AV1 videos. Thank you, Tarek.
That's fantastic. Lots of good news in one slide. Thanks, David, for sharing that. And it's impressive. I want to reiterate on one point you mentioned. It's impressive in general. People see new codec needs to be necessarily more compute. And this curve is exactly showing the opposite. It can go all around the range of low compute and high compute, and there is always efficiency and savings. Perfect. My next slide is from Google. Matt, would you tell us more about Google's development in AV1 recently?
Sure, thanks, Tarek. And I will try to keep this brief because a lot of what I'm going to be discussing here will be touching on in our conversation. But obviously, we have a team that's been very involved in royalty-free open source codec development since 2010, when Google and its open source project WebM released VP8. With AV1, we were involved with the group of partners who are participating in AOM with us. And we released AV1 with the AOM consortium back in 2018, and then immediately started adding it to a variety of services and platforms, from VOD with YouTube to RTC with Duo, and then across Android, Android TV, Chrome, and a growing number of hardware endpoints. And two, I think a point that David made very well about focus on efficiency, not just computational efficiency as well as compression efficiency. We have recently invested in a homegrown ASIC solution for our data centers called VCU, for video coding units. And that's our effort to make sure that we have the ability to sustainably support next generation codecs at YouTube by taking the benefit that Sean will talk about of dedicated ASICs that do AV1 encoding in a very efficient way.
Perfect, thanks. Actually, I would like to bring Sean here as well now, since you mentioned the acceleration. Sean, what is Xilinx plan to contribute in AV1 here? What is your vision?
Yeah, Tarek, that's a great question. And Matt, thanks for sort of the teeing it up and lead off here. So from a Xilinx perspective, as you know, we are the inventor of the FPGA, and so we believe that the ecosystem should have a multitude of varying solutions to choose from, depending upon the workload, the use case, and the deployment style. So we've been working with various partners like Blue Dot and Socionext to have existing AV1 solutions available today on our FPGAs. And Xilinx, as an AOM member, and is also developing our own hardware-based ASIC AV1 implementation. And we believe that there is really a demand for a multitude of solutions. And as we're going to be part of AMD in the not too distant future, again, we will have solutions available through them and partners like Visualer that will have software implementations on x86, and certainly AMD is also a large player in GPUs, and I'm sure in the future there will be solutions surrounding that as well.
This is great, and actually I don't know if people noticed it, there was a recent demo by AMD about software 8K 60 video encoding on AV1, and that was pretty cool demo, I think, to show.
Yes, absolutely.
Perfect. Thanks, Nathan. Sean and Nathan, I'd like to bring you this conversation. And can you talk a little bit about what are the benefits, or some of the benefits of AV1, which makes it really that attractive encoder? What does it add to the ecosystem?
So AV1 adds a number of kind of very interesting techniques and tools that allow you to hit a lot of those operating points that David talked about. I'm at the Chime team, and we're primarily focused on the real-time use case. And AV1 actually has a number of tools that were added by member companies like Mozilla, Cisco, and Google, and Twitch, primarily focused on delivering higher quality experiences for users in the real-time case. So Twitch contributed the S-frame. S-frames allow you to switch between renditions without sending a new keyframe, which is an innovation. that provides a lot of efficiency there. In addition, we fixed some of the frame dependency tracking, which means that you'll never show a broken frame. We added online adaptation for the context models, which means that in a real-time setting, you don't incur the penalties that you would on a multi-pass encoder. There are a number of filters we added that work really efficiently when you start moving along that curve that David showed, and so they smooth out some of the errors. And so what this means is that AV1 really delivers improvements in both the real-time experience, or actually all the experiences, the user experience, in the lowering of latency and in reducing the bit rate. The incredible benefit that we're seeing with the AV1 tools is in the way people are using them, right? And I think for real time, there's been some examples of people like Cisco who've deployed this in WebEx and shown that it gives like significant gains over their previous generation. So AV1 is really kind of a game changer in that it's giving a bunch of new tools that weren't available before that really provide a benefit.
Perfect. I would like to carry on the conversation about benefits. I know different use cases will have different benefits. David, I know you mentioned the compression at a cost, at a lower or lowering even the cost to achieve better compression. What else do you see in AV1 that wasn't enabled before or using previous codecs? What addition it will add to Facebook range of products?
I think, for us, honestly, it's that computational curve is the single most exciting thing. And I've been talking, I guess I'm starting to sound like a broken record, because honestly, I mean, if we think where we were 3 years ago and we had the reference implementation of the AV1 encoder, it was very slow. And it kind of leaves you scratching your head thinking, okay, this is great. I love to see we're reducing these bits, but how is this going to help me? And so it just is, we've been working and it's kind of like, it just keeps giving, right? The more work done to make it faster, we keep expecting that curve to go vertical and stop delivering until we get all the way down to the point where we're running roughly MPEG-2 in terms of computational complexity, and kind of the decision was made. I mean, who knows what else, how far to the left you could go, but we just kind of decided, okay, we think we've covered the practical range and there probably wouldn't be much value in additional optimizations. So I think that's number one. Number two, and I've also been saying this a lot, sounding a lot like a broken record. I think that when you look at where the web is, the world where video is and how it plays in the web, it is such a fundamental piece of the web infrastructure and architecture, and everything we're doing is built on video almost. It's hard to see where you could be successful and innovative and move fast when you're encumbered with royalty-bearing codecs. So I think that also the second really strong value of AV1 is the fact that it is the licensing and royalty terms are very clear. It's free, it's open source, or at least we have open source. There's also closed source tools that are very good, but it's the IP is free. You're able to use this encoder in your use cases without having to figure out the complexities of modern royalty structures, and so I think that the great experiment, the great hypotheses of AOM is video so important that a large population of companies will come together and invest time, talent, and treasure to build a strong codec. I think we can see the evidence both from the encoder, the decoder, we see the ASIC, we all see all this work that's going on. And the answer is clearly yes, that this is the right model for internet video. And so we're really excited about AV1 again, because it's not only a great codec, it's a royalty-free codec.
Nice, lovely. Anush, I'd like to bring you here because Netflix has got lots of, I would say, premium content where pixels, the bits you spend are super important for you guys. And I know Netflix announced 10-bit is as well going to be a requirement for AV1. Can you go through what else is interesting? I know you guys contributed a lot as well.
Right. So I want to address the compression. So while people think of the compression as just a benefit to the members, which it obviously is, right? The compression rate. There's a benefit through the ecosystem. There's a benefit to our ISP partners because they stream less bits of wherever their X servers are situated. There's a benefit to the CDNs because there's lesser storage, right? Which is a cost. And with the increasing catalog, especially for us, that's clearly a very good reason to reduce cost, right? So just bitrate reduction has like multiple partners who benefit. And there's also QoE benefits, right? Reduced bitrates means lesser rebuffers, shorter delays, content starts up immediately. All of these things can be done. You can cache more on your device. So if internet goes out for a bit, you still can continue back and so on. So there is this high quality of experience that people have hopefully come to associate with Netflix that AV1 continues to promise and makes it better, right? And then on the higher end of quality, we have film grain, which is probably not something that you see in consumer video, but you see a lot in professionally shot video, right? And as anybody in the video compression space knows, trying to compress random noises is an impossible problem, right? Compress it properly is an impossible problem. But we want to send that information along to the members because we are intent on maintaining creative intent. I didn't expect that sentence to come out that way. But so our goal is to maintain creative intent the way the creator intended it to be, right? And the film grain noise is one such tool that allows us to do that in an efficient manner without wasting too many bits. The other one that I'm excited about is the HDR space. Before we've had multiple codecs, as I think David was pointing out a while back, that for this use case, we had this codec, and then for HDR, we had a different codec and so on. But AV1 allows us to go across the spectrum. So on the lower end, maybe the bitrate compression and so on. And then on the high end, we are also able to do HDR on AV1, right? So and HDR is, now growing. I don't think you can find a TV now, at least the US market, without HDR on it. And then the final one I wanted to mention also was AVIF. While we speak a lot about video, the AVIF format, which is based on the AV1, is also a fantastic format. Again, the HDR part of it is, again, attractive. Much of the images on the web are a JPEG and WebP. For example, WebP is 420, which is, it's a problem if the company's logo is a red N, right? Clearly, 420 is not the best subsampling to use. But then AV1 allows us to do a lot of things on the UI. It allows us to do a fully HDR UI, for example, with all the artwork coming on HDR to give that pop. So I think there's, as probably David was mentioning, there's a wide range of use cases for us from the low end to the high end.
That's a very interesting list of features that a premium content provider, I would say, like Netflix, need. And it looks like AV1 is ticking most of the boxes. I would like to jump to Matt. I know, Matt, Google or YouTube have been using open codecs probably before anyone else, if I might, at scale. You have V9 already for years. What will AV1 add to you in general?
Well, I think the other panelists have done a pretty good job of capturing the benefits. YouTube services are so broad ranging from at the high end content that looks similar to what Netflix is streaming to very small videos. Maybe David is still sharing his videos on YouTube, not just on Facebook video. But so we have to make sure that we have encoders that are covering that entire range of content. And so for us, we know from experience that if you introduce a new codec, you improve video streaming for all users. So videos start faster, they play more smoothly, and there's less rebuffering. And in general, with each generation of video codec, we can, assuming that we're not topped out on resolution for video, we can give the user a higher resolution than they could get with an earlier generation codec. So there's that streaming efficiency. At the very high end, it's only with the newest codecs that we can enable 4K and 8K. So for instance, even though YouTube still supports H.264, you can't get 4K or 8K with H.264. We don't support 10-bit with H.264, for instance. And so the ability to support HDR and other newer features are only available with the latest codecs. And then for us, we're very focused as well, obviously, on storage efficiency, because the videos that I create and David create may not get the same number of views as the videos created by our most influential creators. And so we have to make sure that and nevertheless, I'm capturing that on those videos on a late generation phone in high resolution, high frame rate. So, and in particular, if I'm capturing 4K or 8K, there's a huge storage hit. So we need to make sure that we are continually moving forward with codecs so that we can provide a really satisfying and cost-effective streaming experience for our customers.
Perfect. What I've been hearing is really a long list of features and benefits here. And Sean, your team develops codecs. How would you address all of these? What are the challenges you're seeing? And this is probably a good segue into start talking about encoder development and implementation. Where do you stand there? And do you think AV1 is challenging or is feasible to go into the hardware and the kind of solutions or platforms you provide for encoding?
That's a good questions there. So I think it's absolutely, we're at a point, I think within the ecosystem and with technology, we are absolutely at a point where AV1 can be deployed. I think, you know, there's going to be a number of solutions that are going to be available. And I think, you know, what we're seeing is the market and the number of applications. Even if you talk about live video, you can now start to splinter that up into varying degrees of latency. And so, you know, these are some of the critical things that AV1 is going to play a large role in, because as you move down the latency sensitivity, or move up, I mean higher, meaning more latency sensitive, now all of a sudden you start turning off some of the advanced tools that have historically helped in reducing bit rates. So AV1, I think, is really going to help here as we're developing, you know, our ASIC. That is a key area that we believe that AV1 is going to definitely play a key role in. And then, you know, I would say certainly there is the ability with AV1 to also get into applications as it starts to be more widely deployed in the cellular smartphone market. I think it'll start to really help us in some of the emerging markets as well. And I think we'll still, you know, we'll need to continue to drive lower bit rates. And again, I think someone pointed out in the chat or the Q&A that this is really coming down to cost, area, and power per channel. And that becomes critical from an environmental standpoint. And we think that the AV1 will really help from an environmental footprint standpoint. And so that's something else that we're driving towards, is really enabling AV1 at a cost per channel that is equivalent to 264.
Okay. With on top of all the compression savings and benefits.
Absolutely.
Interesting. I think that's, yeah, you look at it from a low power, low cost from a hardware point of view. And I know David just started this presentation by showing that slide on the software encoder. And I'd like really to share, or start asking you to share some information about, are there codecs today ready to be used for whatever application, VOD or live? David, can you tell us a little bit more about your effort on SVT AV1 and which areas? I know the complexity. I'm not trying to get repeating what we have, but is it ready today to help you go and use it for your production potentially?
Yes, I mean, SVT AV1 actually is a very strong and solid implementation. It's open source. It's been very thoroughly tested. And so I do believe it's ready to be plugged into any software encoding use case. But I do want to mention that there are also some very strong closed source AV1 encoders where they've gone and focused on unique specific use case areas where they're actually, you know, so I don't want to, SVT AV1 has a beautiful curve, right? From the most computationally expensive all the way down to, you know, to X264 very fast. But I don't want to say that SVT AV1 is the answer for every problem. And so, for example, if your sweet spot, if you're, you know, a premium VOD company showing high quality Hollywood content, your sweet spot is down at the lower right. that's where you're working. And in that case, you know, I from my own personal experience with previous generations, often some of the closed source codec vendors who emphasize a specific point on that curve would be able to deliver a better opportunity. So I do think, again, SVT AV1 is a solid codec across the spectrum of compute, but I do also think there's significant room there for players to build, you know, their own versions of either open or closed source AV1 encoders that target a even better within a range of use.
Perfect. Anush, I guess you guys as well are doing premium VOD. What options do you have, and where are you spending most of the effort, if you can share, in terms of, do you have enough encoding solution? What are you adding to those? Or are you using off the box, off the shelf, maybe LibAOM?
Right. LibAOM is, sorry, go ahead, David. Yeah.
No, I'm sorry. Go ahead.
Yeah. So LibAOM is a perfectly reasonable solution. I think, as David was pointing out, right, depending on your use case, you have options in the ecosystem. I think the thrust of your question is the options in the ecosystem for encoders. I think there are plenty. There may have been a time when LibAOM was the only one, but there's several. There's proprietary ones. There's SVT AV1. There's several companies which have proprietary solutions. I don't want to mention one because then it would feel like they're advertising something. But you just Google AV1, you'll find a bunch of those solutions, right? So it's not unknown that there's so many encoder companies, and that is precisely what we want the ecosystem to look like. You want all of these competitors to work. Each of them have their own niches and specializations where they want to focus, and each of them will cater to a different market. So if the thrust of the question was that do we have enough encoder choices where you can play around with, I think the answer is a definite yes.
Matt, what are your thoughts there? I know you mentioned the VCU, and I know you care a lot about, the volume is huge. So you need lots of compute. Can you share any of Google or?
Yeah, so we use a combination of software and hardware encoders, and my team or our team devotes most of their work on the encoder side to the LibAOM encoder. And the LibAOM, like SVT AV1, has a very strong curve from the very fastest encoding settings where you sacrifice a little bit of quality, but we are encoding at less cost than we were with VP9, which was the predecessor codec, to the very highest, slowest speeds, highest quality, where we are devoting more cycles to encoding, but we're getting significantly greater quality gains. And even at YouTube, the VCU, which was, as I said, this custom ASIC that was designed in-house to provide super cost-efficient, scalable encoding for the vast majority of YouTube videos, is a solution up to a certain point. And then, it continues to be the case that hardware encoders lag a little bit behind software encoders in terms of being able to wring out the absolute highest quality. And so there are some videos that still end up with software encode right now because we can get greater quality from them. And then as David and Anush pointed out, Google has a lot of services that support video, and we explore a variety of options beyond options that our own teams are working on. And as both Anush and David said, there's some very good excellent proprietary solutions out there that may outperform either SVT AV1 or LibAOM for a certain type of video. Same thing holds true on the ASIC front there. As we see more neural network-based tools, other pre-processing and post-processing tools that are codec agnostic, there may be ASIC solutions out there that are better integrated with third-party tools or allow you to do more ML processing in connection with your video coding that merit looking at. For anybody who's interested, maybe one. So it is one of the great things, I think, as we continue to move forward with open royalty-free codecs, is you see this blossoming of various solutions out there, because for large companies, it's not enough to have a single solution. You really want to make sure that there are multiple solutions in the market. And one of the nice things is that there are members of our various teams who've gone out and started these companies supporting the ecosystem.
Indeed, perfect. For purpose of time, I'd like to jump into our next topic, which is decoding. Obviously, if you have a good encoder, that's great, but hey, people need to be able to watch those videos on devices, on platforms. Nathan, I know you have been active contributor. You were at least an active contributor to David. Nathan, can you tell us a little bit more about David, the performance, and the use cases?
Sure. And I'll be very honest, I've got a very small set of contributions to David, and there are many people who've done much more. David is really an incredible piece of technology that sort of was put forth to kind of bridge the gap between the launch of the format and when we will see these sort of ubiquitous hardware decoders. Thanks to the generous donations from many of the members on this call, David now has support for decoding AV1, both 8-bit and 10-bit, across 32-bit and 64-bit platforms on ARM and x86, and basically has what I believe to be the fastest implementation of a software AV1 decoder that is probably possible. I took a look this morning before the call, and the latest version, they're working on a 1.0, which might come out in the next week or so, or next few weeks. There's some things to land first, but the latest version has, I think, 172,000 lines of handwritten assembly, which is just unheard of for even an open source multimedia project. If you look at libVLC and FFmpeg together, they don't have that much handwritten assembly. And so what David has done is it has basically provided a solution for doing software AV1 decoding in browsers, on OSs, on mobile applications, for those use cases where AV1 software decoding is viable. So maybe not necessarily 4K, but at lower resolutions, it ends up being a very, very powerful solution. In some cases, I don't think it's any worse than a software decode at certain resolutions. And so this is really a really kind of amazing piece of technology that's out there that lets people play with AV1 today and solve this decoder problem.
David Drunk, I know you worked with multiple software decoders, and David is one of them. Can you share your effort and what other performance we can achieve now?
Yeah, actually, so we ran a decoder analysis or benchmark a little more than a year ago on the 300 most popular Android phones in India. And what we found at that time, because we were trying to understand, as we deploy AV1, we want to find opportunities where we're actually delivering value to our users, not just hitting some technical goal. And so we wanted to understand how it's going to perform. And at that time, the large majority of the Android phones were only able to decode 360p at 60 FPS, which means you could, realistically, we could do 540 at 30. And at the time, this just felt it was coming up a little bit short. With investments that have been made in optimizations, threading improvements, and also some, taking a good look at the cost benefit of the decoder tools, we've been able to get a new set of tests, the improvements in David, and we've just kicked off a new benchmark. And we will be blogging the results of this. We will be sharing some data. It's going to be probably in December, so I would expect early next year. But what we're seeing now is with all the work that's been done, we're now seeing 720 at 30 FPS as being viable so far across all the devices tested. I mean single threaded. We're able to do single threaded decoding 720p 30 FPS on all the devices we've tested so far. This is preliminary. I don't have the data to say this is the way it's going to be, but we're seeing a huge opportunity there. And then we did an analysis of all the decoder tools, and we found 3 tools in particular that I'm forgetting the names at this moment, that combined offered less than 1% of efficiency win, but they cost significantly to decode. So they were failing the cost benefit. So in addition to doing the test we did last time, just with different types of content, we're also doing this tool off. And that's even showing better results, because that's now allowing us to push up the performance even higher. So expect good news on AV1 decoder software decoder performance. I expect good news, and we'll be talking about this a lot more in the upcoming months.
That's really great. I'm really going to be looking forward to that blog. Anush, very quickly, you mentioned at the beginning of this presentation, TVs, living room experience for Netflix, which is very important. What can you share there? Do we expect 100% of TVs AV1 capable recently, or new TVs at least?
Yeah, that would be the hope. The hope would be 100%. But I can clearly say that the majority of the televisions that are coming out support AV1 hardware decoding. Right? We have certification set up so that for our new generation SDKs, they require AV1 support, and we see that across the board. So it's generally not been a problem for much of the majority. The major TV manufacturers. I also wanted to go back to this software hardware decoder bit. It is valuable to consider different clients. So think of browsers versus phones versus televisions. Each of them have their own upgrade cycles. And it's also valuable to consider that different markets in the world have different upgrade cycles, right? So sometimes phones in maybe the US get upgraded much faster than some other parts of the world. And therefore, this kind of existence of a performance software decoder along with emerging hardware decoder solutions, whether we see a hardware decoder even on Android phones, so it's not just televisions that have it, is the perfect mix for us to deploy AV1. And as someone else was pointing out, even if you can do 720p30, that is as good or better quality because of AV1's efficiency than any other equivalent codec. And therefore, you get that single codec advantage that we spoke about earlier in the call. So hopefully that answered what you were asking.
Absolutely. No, this is really very interesting. I'd like to get Matt's view.
Let me just, I think it's very interesting because one of the things that we're seeing as being call it a foundational technology that spans across multiple, geographies, markets, et cetera. We've added a significant amount of AV1 decoding in our upcoming ASIC, and we believe that as the number of user-generated content starts to come into the cloud, that decoding is going to be critical, especially with some of the applications where, think of a, Chime, Teams, Zoom, all of those kind of applications where now you could be having very heavily decoding and maybe compositing and then redistributing, but we believe that the cloud will also, not only the endpoints, but the cloud will also need very shortly, very high density decoding as well.
Perfect. No, I think definitely that use case is going to be big, and the transcoding part between codecs might require lots of VP9 decoding. And for purpose of time, I'm trying to jump a little bit here. Matt, I know maybe this is a question for you to seg into this ecosystem readiness by talking a little bit more about browsers, decoders, ASICs manufacturers. I know you have lots of visibility there. So what can you share with us, please?
Yeah, so let's see. AV1's very broadly deployed. We added support for AV1 software decode, meaning we shipped with a software decoder in Android 10 and added support for hardware decode, meaning we would, if there was a hardware decoder available on platform, we would support it also in Android 10, and started seeing the first mobile chips shipping at the end of 2019. So there are already devices in the market that are mobile devices in the market that are playing back AV1 in hardware. As Anush said, on TVs, we've seen very early adoption of AV1 across platforms. And I think maybe where you see a little lagging in AV1 hardware decode on TVs is just at the lower end, where there's a little less investment from TV manufacturers in updating the platforms than there are for their 4K and 8K TVs. In terms of browsers, we have very broad support across Chrome, Edge, Firefox, Opera, Chrome for mobile. A big question for many in the ecosystem is where Apple is going to come in on AV1 support. And I'm not privy to Apple's rollout plans, but we do, I think, all know that Apple is a very significant contributor to AOM activities, very active in AOM working groups. And so we're hopeful that Apple support will come out across iOS and Safari sooner rather than later.
Perfect. I'm going to open the question for everyone, and whoever has got any opinion, please let us know. So do we expect from all you guys any remarkable AV1 deployment next year? Are you planning on any launches? Which I know it's sensitive to share, but I know lots of you already are having AV1.
Yes.
Go for it.
It'll be out next year. I'll say that.
Perfect. So we expect some real-time ASIC from Xilinx.
Yes, absolutely.
So this is open for anyone who wants to jump in.
Yeah, without getting into too many details, we do plan to begin, and so far my team has not turned on the AV1 switch, and the reason was the ecosystem wasn't ready for us, right? We didn't feel like it would have been it only would have been, kind of for show. Hey, look, we could check off a box, and for me, the AV1 is a good codec because it's a strong codec, and what we want to do is deliver wins. So we've been holding off while focusing on the opportunity to actually deliver meaningful wins, which usually means by improving customer experience, either reducing play start time, reducing rebuffers, or being able to improve the perceived quality for a given user. So we believe that the tools are ready now, and on both the encode and decode side, and we are investing in 2022. We will be deploying AV1 video out to our users.
Okay, that's really great. Anush?
Yeah, so we already stream AV1 on Android and on TVs where the hardware decode exists, and on Android with software decode. We expect to increase AV1 coverage on Android phones because there's a bunch of them coming out with hardware decode support, so we get to see that. We expect to see it grow in the Chrome and the browser market. One other thing I hadn't mentioned was PlayStation and Xbox. So the gaming console area, we actually stream already on PlayStation Pro, for example, AV1. And we expect to increase the coverage there as well next year. And there's also use cases. So DRM and non-DRM content, HDR. So you're going to see a bunch of these things come up through the next year and maybe stretching into 2023.
That's great. Good future, or at least close reality deployment for AV1 coming soon. I didn't leave lots of time for Q&A. Eric, do we have any questions? I didn't pay attention there.
Yes, Tarek, we've got a number of questions. So let's start with this one. Eric Hers, who is a longtime streaming media event attendee and has been around the industry for as long as just about anyone, is saying our multicast video player for enterprises is QuickTime or Qt with GStreamer with VPA plus Opus and ULP forward error correction. We want to move to AV1 ASAP. Should we switch to SMPTE 2022-1 forward error correction or stay with ULP? Are there any issues with forward error correction and AV1 that I need to be aware of? That's a mouthful, but I'm betting someone can answer it. Or not.
Certainly someone can.
Yes.
The question is, can someone on the panel answer it? That might be a question that we can answer offline more productively. Unless, I don't know, I'm not sure it's somebody.
But SMPTE 2022, is that tied to the 2021 specification for uncompressed?
Yeah, maybe we should take this offline.
Yeah, this is that's great. That's an offline question. The next question is, and this may be beyond the scope of what your expertises are or areas that you want to address, but I think we have to at least acknowledge it. What's the status of Sysvel's channels to the royalty-free nature of AV1?
Yeah, I'll just say you have a panel of marketing and engineering experts here. We do not have a panel of lawyers, and so, as any good lawyer will tell you, engineers should never discuss law, and lawyers should never design codecs. So I think we really have to, just in the interest of
I get
being
it.
good legal citizens, I think we should defer the answer to that question.
Yeah,
I get
I mean,
it, but-
I would say we're a bunch of big companies. We're all here talking about significant deployments of AV1. So, I think you can read something into that.
Mhm.
Yeah.
Sure, makes sense. I just wanted to make sure the issue
Yeah.
was at least out there because it
Yeah,
is in the back of a lot of people's minds.
it's an elephant in the room, right? I
Right.
mean, when we say royalty free, what do we mean? But I do believe if you look at the large set of companies that are involved in AOM and you look at the commitment they've made to the royalty free codec and the willingness to stand behind it, I think that that's a very solid, very strong argument, but ultimately it's an argument best handled by lawyers.
Sure, very good. We had a question about forward error correction that was very specific, but what about error resilience with AV1? Can AV1 tolerate multiple consecutive packet losses during network congestion without negatively impacting QoE?
We got a panel of people who are streaming video, not doing broadcast video, and probably we're all sitting here looking with since I have a past touching in broadcast, I would say that using a packetized model such as MPEG-2 transport stream, where you have the ability to detect discontinuities, then the decoding system obviously once the discontinuities happen has to go through a resync. So there's no reason why you can't do with AV1 what you've done with MPEG-2 video or H.264 as far as carrying it in a resilient packet format like MPEG-2 transport stream.
I guess I can speak a little bit more to that. So there is some error robustness built in terms of like the dependencies between frames for context modeling. So depending on the frame structure you're using, you should be able to detect that the frame you're decoding, is missing the dependencies and not display that, do some kind of error concealment.
Sure.
I think
All right, there are a couple more questions, but we do have to wrap it up. I can save those questions and send them off offline to the panelists. Again, thank you so much for an incredible discussion about what could be a big part of the future of streaming video. Again, thanks for all our panelists. Thanks to our audience for all your questions. Thanks to Conviva, Limelight Networks, Signient, Video Guys, and Xilinx for sponsoring. And I forgot to draw a name to be the winner of the gift card, the $50 Amazon gift card. So everyone should watch their email. We'll make sure you get an email. It'll go out next week. Watch for it. And hope you can join us for more sessions today. The next session will be the multi-platform, multi-device challenge. Hope to see some of you there then. Thanks.
Thank you.
Thanks, Eric.
Take care.
Thanks, Tarek.
VideoGuys.com is your source for PTZ cameras that fit productions of all sizes.
Add multiple camera angles to your production without adding operator. Perfect for houses of worship, corporate AV, education, and more. Video Guys offers cameras from PTZ Optics, Bird Dog, Panasonic, and NewTek. Control these cameras using an IR remote, control app, or hardware controller with serial or network connection.
Go to VideoGuys.com or call us at 800-323-2325 for help finding the camera that's right for you.
In this era of streaming video, we are pioneers, helping make your stories more vibrant. Conviva lives in billions of apps on devices all over the world, measuring trillions of data points each day to provide real-time insights for your content, ads, and social. Conviva. Every stream, every screen, every second.